All right. Welcome, everybody. Thanks for joining us. This is our third in-person event for 2021. We've been having one every week. I think we're going to probably take a couple weeks off for Thanksgiving, but we'll be back in December. Oh, but we actually, no, November 10th. We're going to go tour Hudson Space Systems. So that should be cool, over in Hoboken. And yeah, I'll let you introduce the speaker.
Sure. So today, Rogue Space Systems Corporation is presenting. Okay, Jeremy, go ahead.
Alrighty. Well, first, thanks so much, everybody, for having me today. Really appreciate it. And yeah, Sally's one of our very, very smart people that works here at Rogue. I always say, if I'm the smartest guy in the room, we have problems. So we have much smarter people like Sadia and the rest of the Rogue team help us do some really cool things. What is more cool than robots in space, outside of people in space, but robots in space, I think, are a pretty close second. There's a lot of reasons we would like to use robots in space, everything from safety to sustainability, providing services, dealing with space debris. There's all kinds of reasons to use them. And we're going to talk a little bit about that tonight. So the format that I typically like to go through is I'll hit these slides and I'll kind of run through them, but I can flip back. But I really more enjoy the conversation and answering questions and talking about what's going on out in the space industry and what the different solutions that we're trying to put together for space. So with all that being said, I'm going to start hitting these slides, and if anybody has a question, feel free to ask. But yeah, we'll try and save as much time as we can for the end. Again, my name is Jeremy Grimmett, and I am CEO of Rogue Space Systems. And we don't really look at the problems in space. What we really do is try to focus on what the opportunities are. And we know that we have opportunities across the board, whether it's defense, mega constellations, debris, helping build the next generation of space infrastructure, like space stations and gravity rings, and of course, trying to support and build out a cislunar economy, which can be worth trillions in the coming years. These are all extraordinarily hard problems to solve, but they are well within the grasp of our capability in terms of human ingenuity and the technology that we have available today. So it's a very exciting time. One of the big topics of discussion that we always run into is space debris. And as we go through this, we're just going to be talking more and more about space debris, because every single conversation I ever get into when it comes to our robots ends up being about, you guessed it, space debris. Now, there's over 606,000 tons of debris flying around in low Earth orbit. It's presently about a $3 billion debris removal market. There's, as an indicator for how important this is, over the course of the next couple of days, there's SpaceWorks and Orbit Prime is going to be announced. And those are calls for proposals from the Space Force. Now, the level of priority is signified by an increase of over $2 or $3 billion that the Space Force's budget was increased to $17.4 billion. So we know that the government in space defense is the priority is increasing as we move forward in time. Now, the areas where we're going to be talking about are the low Earth orbit, medium Earth orbit, geostationary. Now, low Earth orbit, that's 2,000 kilometers and lower. Medium Earth orbit is 2,001 kilometers up to 38,000 kilometers. geosynchronous, geostationary orbit. That's that red ring that you see around there. That is where the biggest, most high value systems and satellites reside. Just above that is the graveyard orbit, where they put things that are dead or dying or end of life. So our job is to go and help clear out these different areas within LEO, GEO, and geostationary. Now, an interesting little tidbit is that there are approximately 550 operational geostationary satellites. Across those satellites, there's well over $200 billion worth of revenue generated per year just with those satellites. Whenever you look at the landscape, the top five operators account for $94 billion worth of yearly income from just those five. I want to say it's either the top 3 or top 5 operators across only about 50 assets, resulting in approximately $94 million a year per asset being generated. That is a massive amount of investment. And then whenever you look at the time it takes to get that asset into geostationary, you can see how a 3 to 5 year timeline is not the best thing. That's where Rogue starts to come in. That's where mega constellations start to come in. That's where the small sat community starts coming in. And all of that needs to be managed, needs to be maintained, needs to be sustained. Debris needs to be removed, failures need to be mitigated, and that's where our robots can actually come in and help. Just talk a little bit about space industry. We're just going to skip this one because I already gave these numbers, more or less. So we're a first of its kind organization. We have some partnerships that are allowing us to move very quickly. We were established here in Hampshire in 2020. We're positioning ourselves to be the AAA of space. We got a problem on the side of the road called AAA, and that's where we're trying to position ourselves. We have the ability to save hundreds of millions of dollars to space operators, and we're also looking to have reusable autonomous transport services and even develop service stations in space. But that's all I'm going to say about that, because that press release isn't out there. So I'm not going to say anything else. Now, the way we do that is we are looking to develop these particular robots. Now, we have 3 of them. The first one that we have planned to launch is Laura. That one's going up next year. But the cool, really cool one is Fred, and he's got 4 robotic arms. He will probably be launched close to the end of 2023, early 2024 on a rocket that we've already contracted. Laura, on the other hand, is focused very much on inspection, monitoring, observation. Now, the reason Laura is so important is because we take all the technology that's in Laura and we iterate and put that into Fred and ultimately Charlie and Bob, who's not a picture here. So we take that technology, don't have to redevelop things, and Rogue focuses very specifically on specific technology. We focus specifically on technology within the spacecraft that elevates its capability. So we're not going to rebuild or figure out how to design a reaction wheel. We're not going out there to develop a flight computer or things that already exist, solar panels, things like that.
Recording in progress.
We take existing technology and then we apply our own special sauce, our own special capability, our own systems, and we elevate the capability of that spacecraft. The way we do that is we put in our specially designed thrusters, our artificial intelligence that take a normal 12U CubeSat that would normally operate maybe 3 axes, we have the ability to maneuver in 6 axes. Normal CubeSat might have a couple hundred meters worth of delta V. We have over 600 meters per second worth of delta V. Our systems are designed to fly around in different orbital shells, change inclination, altitude, things like that. We're mobile. We're not a fixed, pointed satellite. You're a vehicle. We're truly a spacecraft. So that's some of the big differentiators, and that's how we look to deliver these capabilities in space. Now, we provide a pretty hefty value proposition. We did an analysis where we were able to save an operator roughly $42 million a year in GEO. That's pretty substantial. That's using some real life scenarios and data that we were able to collect across some various insurance claims and failures. We can increase satellite lifespans, power augmentation, refueling. We are on demand, so we will have our spacecraft repositioned in various orbits that have high traffic and have high demand so that we can get there in a timely manner. And we're looking to try and repair and not replace those assets and increase that lifespan and increase that system's long-term ROI for that operator. So we do have LARA-1 planned to launch in 2022, and Orbital Assembly, they are planning to launch their demonstration mission for the orbital ring that they are developing. That ring is going to generate about 1/3 gravity in space, in low Earth orbit, and on high inclination. And that's really exciting because the idea here is that they would be able to maintain longer-term occupancy of astronauts in low Earth orbit. That's a big deal. Instead of being limited to just our existing space station, we would have actual gravity that someone would be able to operate in and live in for a much longer term. So we're really excited to be a part of that, and that's, I want to say they're going up into 2023, Q1, Q2, 2024. I want to say that's a timeline. Now, our overall roadmap strategy, funding strategy, and we are targeting lunar for 2024, 2025. We are presently in a CRADA with the Air Force Research Lab, and we're in the process of expanding that in-kind CRADA over the course of the next several weeks. They've already covered our LARA-1 and LARA-2 launch costs, but they are looking to try and expand that to LARA-3 and 4. So pretty exciting stuff, and we're excited to conduct those missions for Air Force Research Lab. Our team is made up of, now this is just our short slide. There's myself, Mike Pica, my co-founder, Chief Innovation Officer, John, our Chief Operations Officer, Tim and Michael. All of us have some level of either very deep robotics or artificial intelligence knowledge, and to support the business-minded, the business mindset that we have, and I'll explain that in a second, we brought in some pretty important key players. Griff Russell, our Director of Space Operations, his claim to fame is he led the engineering in SpaceX that landed the first Falcon 9. So if you want to know who got that done, that was Griff. Catherine, she ran a couple of missions with NASA JPL and OAA, quite a brilliant woman. and James Africano is heading up our defense business development efforts. He was a contracting officer and just recently separated from Space Force, which is very exciting for us. The way that we kind of came about is we didn't have a technology to start off with. The way Rogue actually came about is we figured out what is the business model, and how are we going to operate the business, and then what are the technologies that would support that. A lot of space companies, a lot of startups are kind of the opposite. They have a technology that they want to develop, or that they have developed through a thesis or PhD, and then they want to go and market that technology out to the world and go make money with it. Well, we didn't go that way because we're business people and we're nerds and we like to do cool things in space. So what we did was we came up with the business first. We identified our market. We strategized on how we could go about doing that. And we assumed that the technology is there and available. And for whatever gaps that we had with that technology, we then went in and we put our efforts into developing that technology. And that's where people like Sadia kind of start coming in to help us do stuff like that.
Just a quick intro, I'm Mark. I used to work for European Space Agency, now residing in New York. Like a question about your positioning, like you mentioned you are the first like AAA for space. I know there are like multiple projects working on the similar stuff, including like Lockheed Martin and other like bigger players. So can you a little bit expand about your competition and like the landscape you are working in? Thanks.
Yeah, I don't, again, we kind of take a different philosophy to the entire approach when it comes to competition. D-Orbit, Lockheed, Norman is the fact that our vehicle, like, so Fred's a perfect example, and he's on the screen right now. Fred's a perfect example of we are not trying to do any one thing, but we're trying to solve a number of problems by using a dynamic and flexible platform. So this has 4 robot arms. It has a suite of sensors. It's got all kinds of really, really powerful capability on it. The thing that's here that a lot of other groups don't have is a tool belt. So we can swap out sensors at the end effectors. We can swap out the end effector itself. We can deliver a capability to the vicinity of solve it. Well, we don't believe that there is any one solution. We don't believe that. We think that solving the servicing, solving the refueling, solving space debris is going to require a number of different solutions. There's not going to be any one silver bullet. And we want to be the platform that supports the delivery of these varied capabilities. Could very well be Astroscale or Lockheed or whomever, they catch a ride with our system to get to a target that they want to acquire, capture, and remove. That could be a thing. And those are the types of conversations that we've been engaged with a number of different quote unquote competitors. So I hope that answers your question.
Yeah, perfect, thanks.
Any other questions?
Space debris that are currently sort of on our horizon that you'd be targeting? Like, are there things that you see come up time and time again?
In terms of location, yes, we actually have some analysis that we're doing to kind of identify where the most pain is. In terms of specific objects, we do have a list of the highest threat objects. Sadia was actually one of the people that helped develop that list. One of the One of those objects is DMST 5D-2 F-13. That doesn't make it's a defense military defense meteorological satellite program. There was a battery that exploded on it, or that's what they think, and it went from 47 TLEs to I want to say it's either 60 or 80 TLEs now. So it's continuously breaking up. But we really don't know if it was the battery that blew up. We don't break up. Was it the battery? Take Kobe, for example, the Cosmic Observatory. It's called Kobe, COBE. It's breaking up as well, but they don't know why. They think that it's insulation, but they can't say for sure. And that's causing more and more pain. It's causing more and more danger in low Earth orbit. So the pain, the space debris, everybody says, okay, space debris is a really big problem and we need to do something about it, but no one's actually taken responsibility for it just yet. Now that's where the Space Force has come out and said, hey, we're gonna pay commercial companies to go and take care of this problem. That's great news, fantastic news. And of course, Department of Commerce is gonna come in and they're gonna help support the traffic management. But to kind of put a finer point on this, the debris is a problem because it's garbage and we don't want it polluting up the space environment. But that's not really what it's about. What it's about is the launch and access to space. That's the problem, okay? Things flying around and blowing up another satellite, yeah, that's a big problem. A few years ago, a launch window was 3 hours, okay? You had 3 hours to get your rocket off the face of the Earth into your slot. Yeah, that's because increased access to space has then congested the low Earth orbit, which has resulted in increased debris, which decreases access into space, which then poses a national security threat, which then prevents us from being able to replenish and support assets in space. So it's a domino effect, and it just cascades, much like the Kuiper problem that we're all worried about. So I know that was a little bit of a longer-winded explanation, but I hope that got your answer.
Yeah, definitely. I have, I guess, a follow-up on something that you mentioned, if you don't mind.
No, not at all. Go ahead.
So is part of your plan, your strategy, to first start with observation?
No, it's not really a lack of data. It's a lack of faith. And so let me explain that. Space is the great conundrum whenever you've got a startup and you're trying to get things off the ground in a very literal sense. And what I mean by that is that if you go and talk to commercial customers, potential commercial customers, they say, well, if you put it up in space, have you demoed it yet? You got a prototype? Well, no, we haven't. We're trying to get a letter of intent, a MOU, this, that, and the other, that says you would be interested in this service. Okay, well, whenever you do demo it, then come and talk to us. Okay, fine. So then we go to AFRL, we go to defense. Hey, here's this amazing capability. It can do all this really cool whiz-bang stuff. Imagine having your own R2-D2, but for real. Okay, imagine how amazing that would be, huh? Well, have you flown it yet? Have you put it into space? Well, no, that's why we're talking to you, because we want to get funding so we can make this happen. Hey, Mr. VC, you got this cool thing. Commercial says they want to buy it. Defense says they want to buy it, but they want to see his demo. can you give us some money so we can build this thing, put it on this rocket that's already paid for by the government, and we're going to show them how we can do this. I don't know. That sounds a little too adventurous for our venture fund. So it's a chicken and egg thing. And you got to go through these processes, you got to go through these cycles, and all you can really do is demonstrate that you have a team, that you have a capability, you can hit milestones, and eventually someone comes through with funding, which, knock on wood, we've got some solid traction on. So, yeah. I hope that answers your question in a roundabout way.
Cool. Thank you.
So Jeremy, hey, how's it going?
Thanks, Chris.
Hey, so with LoRa, they're saying that LoRa itself, with the capability of observation, it would suffice for that demonstration. So it's almost sort of just the demonstrator for threat, is that correct?
Kind of, sort of, but and I think this goes back over to the previous question, which is you also have to understand that it's an iterative design. So you start off with a basic system, a basic concept, a basic functionality that the market needs, the minimum viable product, that MVP. And inspection observation is that thing. LoRa is the embodiment of that capability. It's a platform where we can test out our AI, test out our computer vision, test out our capability, and then we take all of the technology that we have developed there, and we take that exact time, the whole bit. So this is a baseline capability that's needed across the board.
And I understand I think you may have mentioned it before, but you guys already have like a ride share type situation where you guys can get to orbit with LoRa already. When is that scheduled?
That's next year. That's Q3, Q4 of next year. So yeah, you're right. We do have a cooperative research development agreement with AFRL, and they're paying for our first two missions with LoRa 1 and LoRa 2.
And they already have specific satellites that LoRa is going to service?
Not service, but go and observe. And we have a list.
Service with observation.
Yeah. We have a list of targets because we don't get to control the LTAN and the launch window. So we basically had to make this giant list of where we could go with the Delta V that we have in order to execute the mission.
All right.
Awesome. Thank you, Jeremy.
Yep. Thanks, Christopher. We have Elizabeth Kennick from Teachers in Space. You ready?
Yes. Hi, Jeremy. Thank you
Hey,
so much
Liz,
for your
how are ya?
presentation. I had heard about you guys. I have a social media friend, Teresa, who I think was working with you and had called me and told me a little bit. So it's exciting to find out what you're really doing. We are starting to put CubeSats into space. Teachers in Space does educational spaceflight experiments. We have a 3U CubeSat going up, and we had to do a whole lot of work about the orbital debris assessment to make sure it was really going to burn up.
Sure.
And I'm thinking, as this expands, I know we're not the only ones doing it. Is there a concern about littering lower Earth orbit with these educational CubeSats? And do you foresee a time when robots such as yours could guarantee?
Yeah, we're gonna take care of it, and they're just gonna zip around. Unfortunately, orbital mechanics and that darn equation doesn't let us go quite that far. But most everything that's, I want to say 300 kilometers or so, I want to say it's like 250, 300 kilometers, that usually burns up within several months. It's once you start getting into that 500, 750, 800 kilometer, you get within about 250. Woo, man, that's where things get a little crowded. It's almost like a New York subway in rush hour, or at least the way it used to be.
So although our unpropelled CubeSats won't stay up for very long at 300K, that at least is safe in terms of debris. It's good that that's where they're going.
Yeah, I would actually have to ask Rob exactly what the altitude is. I want to say it's like 250, 300, and there's enough drag on it. There's enough, because there's still atmospheric drag out there. There's enough atmospheric drag to bring it on down within like 9 to 12 months or something like that. That's more Rob's department. I stay away from orbital mechanics. So, but yeah, typically that's pretty reasonable. And the tools out there are getting better and better to help with that.
I would love to connect with you separately later to find out if we can include what you're doing in the professional development workshops that we're providing to teachers next summer.
Oh yeah, that'd be great. We're always looking for opportunities to work with teachers and kids and expand educational opportunities. We're even working a thing now on the rocket that we have contracted to give away a few slots.
All right. Anybody else? No?
I have a question. Jeremy, what challenges do you see in the ongoing future in satellite servicing?
I think it's going to mostly be traffic management. I really think that's going to be a big thing, is just management of the traffic, especially in low Earth orbit. Whenever you start getting into MEO and GEO, it gets a little bit easier. Cislunar, that's a little bit easier. The problems, the real pain as far as debris and traffic management is going to be in LEO. That problem has a few layers to it. One, knowledge about what's flying around up there at any given point in time. The tools that we have, Leo Labs is doing a pretty good job, but their radars are only going up so far. And then, of course, you have inclination and orbital plane changes that are occurring. And that's going to happen more and more frequently when it comes to servicing and moving product and moving services around in space. So you got to have somebody that can actually manage those flights just like you do right down here on Earth. You got to know where the planes are flying. And there's got to be some rules. And right now it's the Wild West and there are no rules, which is kind of good, but also really bad. So yeah, I think that's probably our biggest set of challenges.
Hey, Jeremy, just want to piggyback on that one. You're talking about how there's really no sort of traffic management authority or observation for a lot of this, or there's at least gaps in it. With LoRa's sole purpose being looking at other satellites, is there any way for you to incorporate the location of satellite data and provide that as a service? Additionally, because if you have a constellation of LoRa satellites out there, most satellites, you say, are like either looking at Earth or looking at the stars, but not really looking at each other. But if you already have this constellation that's like, hey, I have total situational awareness of this particular region, I'm willing to provide that to you as a service. Is that a potential for Rogue as well?
It is, but so it really depends on the sensor outfit that we put into a LoRa or something similar. The reason being is that LoRa is specifically designed for up close, personal, rendezvous proximity operation types of maneuvering. It's not really designed for like long range scan or identify track. It's not really what it's designed for. So the camera outfit, the camera sensors that we have on there, it would need to be a different sensor set. But the idea that you have is certainly sound. And there's actually been some requests for information by the SDA or Space Operations Command specifically for that type of capability in GEO. But I want to say those are payload capabilities that they're looking for. But yes, the concept is certainly sound. It's certainly something that we are looking at, but it's not something we're doing out of the box.
Awesome, thank you.
Mhm.
Yeah. Are you? You said you're raising money again. Is that correct?
Yeah, so we just closed out our pre-seed round. We raised $500,000 in the pre-seed and cash, and then the 1.1 million in-kind CRADA. So total funding at 1.6, and then now we're looking to raise an $8 million seed round, which will put us into space and get us a couple of builds started on our the next iteration of our spacecraft. So, yeah, absolutely. If anybody wants to chat about that, happy to go through it. Sadia's got my info, but you can reach me at Jeremy, Jeromy, @rogue.space. And as a matter of fact, you know what? I think I can throw it in a chat here. Yes. So I'll just put my email here.
Yeah, anybody could ask me afterwards for his contact as well.
Yeah, and Sadia's got me on Microsoft Teams, so she can reach me pretty much anytime. I really if there's no other questions, I really appreciate the opportunity, and thank you guys so much for the time. And